Olympic lifting, chapter 11. Olympic lifting, chapter 11. Introduction. The scientific rationale for incorporating the Olympic lifts and their derivatives to enhance sports performance is evident both practically and scientifically. As performance specialists become more knowledgeable in the process of program design, more information on Olympic lifting is necessary to make the most effective exercise recommendations. It is important to know the proven effectiveness of the Olympic lifts, as well as to illustrate the established technique for properly executed lifts. Olympic weightlifting is a sport in and of itself. Competition lifts include the snatch and clean and jerk. While these lifts can improve explosiveness, even more popular among athletes and sports performance professionals are the derivatives of the Olympic lifts, such as the power snatch, power clean, the snatch and clean pulls, squatting and lifting, squatting and deadlifting. One reason these derivatives are more widely accepted is many athletes cannot achieve the deep positions necessary for the standard Olympic lifts. Such as the power snatch, power clean, the snatch and clean pulls, squatting and deadlifts. One reason these derivatives are more widely accepted is many athletes cannot achieve the deep positions necessary for the standard Olympic lifts. The sports performance professional needs to know how flexibility, mobility, stability, posture, and neuromuscular control affect the athlete's ability to execute the Olympic lifts and their derivatives. Also, the Olympic lifts are often performed improperly, reducing their effectiveness and potentially leading to compensations or injury. Here, the focus will be on the techniques and considerations necessary for safe and effective performance of Olympic-style lifts in sports performance. The scientific rationale for Olympic lifting. Olympic lifting versus resistance training. Countering some of the controversial wisdom and common practices in the use of Olympic lifting among athletes, Ruslow and Smith concluded there is insufficient evidence to support the greater effectiveness of Olympic-style lifting when compared to traditional, slow, and heavy weight training in enhancing muscle power and athletic performance. This may signify the fact that different training methods may help athletes achieve similar results. Rather than viewing this as an either or matter, sports performance professionals should view Olympic lifting as one of many tools to improve power among athletes. Olympic lifting should be evaluated for the use of the individual athlete and applied based upon their needs and goals within an integrated training program. Principles of specificity training. Recall that exercise selection is one of the acute variables that must be considered in any program design. Thus, the exercises chosen to improve performance in a particular sport should follow the specific adaptation to impose demand principle. The concept of specificity was first put forth by Delorme in 1945. Bompa explains this principle by stating an exercise modality specific to the skill of a particular sport will elicit a more rapid performance enhancement. Sif points out There are at least 10 variables when considering the idea of specificity, such as velocity of movement, force of contraction, muscle fiber recruitment, movement pattern, muscle contraction type, range of movement, metabolism, biomechanical adaptation, and flexibility and fatigue. Myriad sports requires explosive power to be successful. The Olympic lifts are a valuable set of exercises for a program designed to enhance explosive Myriad sports require explosive power to be successful, and the Olympic lifts are a valuable set of exercises for a program designed to enhance explosive power. In applying the said principle, it has been suggested that 7 independent qualities contribute to an athlete's power capacity: maximal strength, high load speed strength, low load speed strength, rate of force production, reactive strength, skill performance, and power endurance. The Olympic lifts have been shown to improve many of these qualities. Sif goes on to explain how the principle of specificity can be confused with simulation training by stating the said principle looks to enhance the variables specific to the demands of the athlete's sport. Simulation training is mimicking the specific sport skill that may be resisted lightly with bands, tubes, or weights, so as not to interrupt the neurological movement pattern. While the Olympic lifts do not mimic many sports, they do develop the specific variables necessary to enhance performance in sports requiring explosive power. In fact, the second pole phase of the snatch and power snatch exhibit the highest power outputs of any resistance training exercise. These two exercises alone will increase velocity of movement, high load speed strength, and rate of force development, while maximum strength can be enhanced by squats, clean deadlifts, and snatch deadlifts. In this respect, the Olympic lifts adhere to the said principle and can be potent exercise selection within a program. Reactive strength is a ready response to a stimulus that would be the necessary strength in response to some sort of stimulus, be it physical, visual, auditory, etc. Power endurance. An athlete's ability to sustain high power output for an extended period of time. Athletes with exceptional power endurance might be 400-meter sprinters, 400-meter hurdlers, individual medley swimmers, or wrestlers, for example. Rate of force development. High load, and low load speed strength. High load and low load speed strength. Low lows, girl. Work output has a speed component based on the characteristics of the hyperbolic force velocity curve. According to the force velocity curve, the highest forces are generated at slow contraction velocities. When converted to power, these motions are at lower power output due to the longer duration of time necessary to execute the movement. Low loads can be moved at high contraction velocities. That is quickly. When converted to power, these motions are at higher power output due to the short duration to execute the movement. Rate of force development. Force is not produced in a square wave response, meaning strength doesn't immediately progress from nothing to maximum force. The mechanical, electrical, and elastic properties of the neuromuscular system respond in an orderly manner that takes time in milliseconds. The rate of force development is the time from the stimulus to reach the required force. This can be measured during a muscle twitch as time to peak tension in an isolated muscle preparation. In humans, it is measured during an isometric contraction, either voluntary or in response to an electrical stimulus. Skill performance. Page 391, going to 392, chapter 11. The Merriam-Webster Collegiate Dictionary defines skill as the dexterity or coordination in the execution of learned physical tasks. The learning of a new skill follows a predictable course whereby unnecessary motor units are eliminated and the skill progressively becomes regulated to almost a subconscious level, executed almost in a reactive state. Skills are learned through a process called deliberate practice. Practice that is not inherently fun. Deliberate practice. Deliberate practice. Movement patterns and range of movement. The said principle, in part, recognizes that in order for an exercise to improve performance, it must display similar movement patterns and range of movement of the targeted sport skills. Regions. It must display similar movement patterns and regions of movement of the targeted sport skill. The Olympic lifts fulfill these criteria through the Universal Athletic Position, or UAP. The Universal Athletic Position is the most common position in sports. It is easily recognized as the static starting position, such as a linebacker's ready position or the defensive position in baseball. It is also seen dynamically, as in the counter movement jump or the second pull phase in the snatch or the clean. It is also seen dynamically as in the counter movement, so the universal athletic position is seen dynamically as in the counter movement jump or the second pull phase in the snatch or the clean. This position is described as being in a standing 1/4 squat with the feet flat, weight on the balls of the feet, hips back, knees over the toes, shoulders over the knees, and a neutral spine. Because posture modulates the ability to generate strength. The UAP, Universal Athletic Position, ensures a posture where the maximum force can be generated from the hips region of movement, one of 6 factors in specificity. To exhibit explosive power, the athlete must avoid movement of the spine. The spine must be neutral and stable to generate maximum power through the hips, knees, and ankles. The Olympic lifts, when performed correctly, move through the universal athletic position between the first and second pull phases, allowing the powerful hip muscles to explode the bar vertically. Empirically, the Olympic lifts augment explosive power for the UAP and therefore increases sports performance. Neutral spine, a posture in which no exaggeration of any of the normal curvatures of the spine is present. A posture in which no exaggeration of any of the normal curvatures of the spine. Low back tuck, arch in the low back.